Hello. In this video, we're going to talk a little about R. And I say a little because I really don't think you can teach like R or programming as an information dump. Like here is a table of all of the data types in R. Here is this, here is that. I really think you need to learn by doing and to pick stuff up as you go along. So this video is intentionally intended to be pretty basic. It's just showing you the absolute fundamentals that we need to start picking more complicated material up. So let's talk a little about variables. And we're not going to give any sort of deep computer science specific definition here. A variable is just a quantity you can measure. And what makes a variable variable is that if you measure it at different times, it might take on different values. So a quantity you can measure that can take on multiple values. And we work with variables every day in R. And I suppose every programming language. It's quite fundamental. So we might, for example, have a variable called number underscore students that measures the number of students in my college algebra class. And one semester it might be 20, another semester it might be 25, another it might be 18. So you see it's a quantity that can take on multiple values. And in R, the way we assign a value to a variable is variable name less than symbol hyphen value. So a backwards, right to left facing arrow. So if I run this code, we'll see these documents. They're called markdown documents. We'll see them later. But for now, all you need to know is that when I press this arrow key, code is going to run. When we run this code, the variable number students gets 20 assigned to it. And now if I take number students times 4, this is my credit hour production. College algebra is a 4 credit hour course, so the total number of credits is the number of students enrolled times 4. When I run this, you see we get 80. Number of students is currently 20. Come on, work with me. There we go. Number of students is currently 20. 20 times 4 is 80. And if I change the value of the variable, say 2 students drop the course, so I change number underscore students to 18, and then I and run that code. And then I go down to number underscore students times 4 and I run this code. You see the output has changed from 80 to 72 because number of students has changed to 18. 18 times 4 is 72. You'll notice how, what this output looks like. There's a 1 in brackets, and then the number we care about, the 72. We'll talk a little more about the number in brackets later, but basically it's just a row number. And we have a single row here, so row 1, value 72. You can ignore it for now. So in R, let me see, there we go. There are a few types of variables. And I'm not, as I say, I'm not going to like create a chart of them for you, but fundamentally it's probably obvious that the variable number of students and the variable student names are different somehow. So fundamentally, in one dimension, variables can be numbers, variables can be characters, and characters can be logical. This is not a perfectly true statement. There are a few other valid data types, maybe just one other valid data type, but this is the stuff we work with daily in data analytics. So as for numbers, I don't have a lot to say because I don't want to get lost in the weeds here. I will point out, if you've worked with Python, this won't be a surprise to you, that R has two different data types that both store numbers. An integer like 5 and a non-integer like 7.6. In most practical situations, we don't really need to worry about the difference between them. I mean, there are reasons to, but for example, you can take an integer and you can take a non-integer and you can add them together just fine. Like the fact that these are different data types doesn't break your code in unexpected ways, at least not usually. Characters, I'm just going to call these strings because that's basically what they are. These are how we store words or sentences or even bigger chunks of text in R. Character values get quotation marks around them. So if I want to assign the value Gregory to the variable name, its name, then this left-facing arrow, and then Gregory goes in quotation mark. Logical values. Again, if you've taken any other programming class, this is going to be very familiar to you. Logical values take logical variables, I ought to say, take on values of true and false. So I can take is underscore prof and assign that to true. Or rather, the opposite, assign true to is underscore prof. True is a word, but it is fundamentally different from a character. It doesn't go in quotation marks. It has to be in all caps. If I don't have all caps, I get an error message. So let's say we're talking about me here. My name is Gregory, and either I am a professor or I'm not a professor. And since I am a professor, I assign a value of true to it. Booleans are really important, um, as we will see. I don't know. I mean, it's probably obvious, like numbers all the time. We see these in spreadsheets. Strings all the time. We see these in spreadsheets. If you haven't done any programming, I'm not sure if it's intuitively obvious that these logicals are also very important. Um, but like we'll talk about if statements later. So I won't go in here, won't go into detail, cannot speak today, sorry about that. But we can make statements like if is underscore prof equals true, do something. Remember that ha you have to take your cyber security training. Everyone's favorite part of working at Chadron State College. And now I can run this code chunk, and if is underscore prof is true. So because is underscore prof is true, this string is going to display, just as I said. So these, obviously, these are the basic, um, but I'm going to end this variable here. As I say, I don't want to get lost in the weeds. This is not a dedicated programming course. This is a data analytics course. And with this and a few other lessons, we will have the background we need to start doing data analysis.